Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode we're going to discuss about Falcon Heavy's second paid mission. So let's dive right into it and let's talk about STP-2. So what the hell it is? Basically it's the third launch. Now first launch was a demo mission, that's why it's not counted here. So this is a second paid launch. Now this happened on June 25th 2019 and 6:30 UTC Universal Time Coordinate. And then you will ask who was the customer. The first customer was Arabsat. This was Department of Defense. Now this is a very big step because in earlier times Department of Defense simply did not allow SpaceX to apply bids for their launches, but then there was a large court case, public hearings and all that, and then they have solved this issue. So now SpaceX can actually go for Department of Defense contracts. This is the first time they are actually doing it. It's not just like okay on paper, but this is time they are actually doing it. And on top of that, this is the foundation mission, because after this the third mission would be there. That would be from Department of Defense. That would be a secret mission. That is like to maintain that secrecy. It is very hard to get approval from government. So this is a very big mission for SpaceX to okay, now we have actually earned the trust of government. Now the cost of this mission is a bit high. It's around 165 million from SpaceX part. Now why it's so high if other missions were done at around $90 million? Simply Department of Defense, government, lot of red tapes. On top of that, it has upwards of 25 satellites inside it. So you have to understand that the payload fairing itself is very expensive, and it's a first night launch. And this, all things combined, the fact that it's from Department of Defense, the fact it has 25 satellites, most of them will require reboost burner of the second stage. That means they have to push the Falcon Heavy to its maximum capacity. So it's really tough on the rockets. That's why they are asking so much, because in the early on the mission they were yeah, there is a very serious chance we may not able to recover boosters. So this is why it's so expensive, and it's the second time. Now this is the insignia for that STP-2. So there are many payloads about it. However, there are certain payloads that are open to public, that as in you can understand the full detail of it. So this was Cosmic 2. Now this is a very big achievement, simply because it's one launch, 6 satellites, each satellite weighing upwards of 277 kilos, basically more or less same as Starlink, and they all are in different inclination. Let that sink in. They are when we are talking about SpaceX launch of Starlink satellites, they were thrown in one orbit and they will space themselves out. This, they were going in different directions, so that is very important. And this is a whole constellation in one launch, different inclination, and it will do basically space weather research. Now of course it will also do climate study and all that. So basically it's a general purpose tool specialized in space weather. And the payload adapter needed for this is what primarily drove the cost so high. And there are some other quote-unquote open quote-unquote Department of Defense contract, which includes one radar that somehow can track a vehicle on land. Radars are generally never used from space, simply because they don't have enough power to actually provide enough resolution. They can see big ships but cannot pinpoint cars and all that. That is one mission that is also launched with this. Now again, that's a demo mission, that's a testing mission. So once they have figured out the antenna technology, the phase shift array technology, then they will utilize that. So that is made for basically if they are gonna have satellite and they're gonna track a vehicle using radar, not optical system, using radar. So weather will not play any role into it, and jamming it would be flat out impossible. So that Department of Defense is doing some things. Then we come to the interesting part. This is for basically future of space itself. There are 2 propulsion testing going on in this time. First is LightSail 2. Now LightSail 1 was a demo mission which was launched very early on, and the idea was, can a solar cell even survive space? Because it's one thing to say okay, we're gonna make it very thin. Does it survive basically radiation pressure? Does it survive the hot and hot and cold side temperature difference? So that was tested in LightSail 1. Now in LightSail 2 they're gonna launch this, and I have provided the link down below. You can check the whole unfolding video. It's quite interesting to see. And the whole point of this is not that just go to space. That has been already established that it can do that. They have to increase the orbit. Basically they have this circular orbit, and they have to make it elliptical and increase the height to it. Now there is a set amount of time. Now if they take longer than that, again depends. If their time frame is 2 months and it takes 2 months 1 day, that's acceptable. But question is if they are expecting the solar pressure to be enough for 2 months and it turns out it takes 6 months, then the mission will be cancelled. But again, this is more of a research tool. This is fundamental level research. Now will this be used in NASA missions and all that? Unlikely. Why? This does not make too much sense if you're going from Earth to Mars, because you need a laser to push on it, otherwise it's useless. And in further you go, the weaker the sunlight becomes. So it's flat out useless if you're trying to go to, let's say, Jupiter, Mars, Jupiter or Pluto. So this will be only used for CubeSats, A, because they are very small, B, CubeSats are generally built in school, university and all that, basically low budget satellite. This is a very good utensil for low budget things. So it does have some potential, and it is a fundamental testing of actual technology. Like LightSail, we have been knowing about this like from 1980s, but we never used it. This is the first time using it. It was launched from a CubeSat, and I would urge you to watch that video. It's quite interesting to see how it unfolds. So let's see what happens to that. It will take few months to find out like exactly how it happened. Then we come to green propellant infusion mission from NASA. You can check my last video about green propellant. Now again, that's also not this mission itself is not important, but the technology that it's testing is very crucial for the future, because if this works out, college and university can now create basically CubeSats or even bigger satellites, and they can fuel it themselves. Right now they don't fuel it themselves. They have to send it to basically NASA or whatever company that is handling the satellite, and they have to refuel it. And to give you a context, that itself costs more than like that. Handling that is very difficult, so it costs a lot. So your whole satellite could be $100 million, and $10 to $30 million would be kept just for hydrogen launch, fueling of it. So if this works out, again, it will unlock new things. If this works out, solar sail, it will unlock new things. So these are fundamental foundation technology. So this is very important, not that radar thing, not that weather satellite thing. These two missions are very critical for the future, especially for low budget satellites. Then we come to one long-term goal, is that deep space atomic clock. Now, if you are not familiar with whole detail and theorem about basically atomic clock, you can check my detailed video about it here, and you have to understand it. We already have a lot of atomic clock. However, this one is ultra precision mercury ion atomic clock. Now, to make atomic clock, you have to go down to atom. Now question is, what are you going to use? So like, to give you a context, GPS generally use rubidium based atomic clock. Now this is generation 1 of Constellation. There is another one that is from European Union, and that utilizes hydrogen. Basically you have to have pure elements, so hydrogen, rubidium, whatever have you, and this time they're using mercury. Now you might be like, shouldn't hydrogen be the best because it's the lightest and it will have highest frequency? Well, yes and no. You have to understand, when we are talking about atomic clock, we are not just talking about the frequency that atom gives off that you're gonna trace. You have to also understand how reliable it is in long term. Basically these clocks, basically they are getting calibration signal from ground based atomic clock. They are very good, but they have to be recalibrated. This on the other hand, they should not need to do that. That's the whole point. That is why they are making ultra precise. Basically it will drift, but they will know how much it has drifted, very high accuracy. Now this is a very backbone kind of technology. You will not see anything coming off of it directly, but same as propulsion mission, this will lay the foundation of the next mission. So this is the time where actually reducing the launch cost has actually started to bring basically, let's say, change, because you have to understand all these three missions that I'm talking, green fusion mission and mercury ion clocks and solar sail, if before SpaceX they would have required so much money, they flat out would have never gotten off the ground. So the fact that these three missions are happening, such a low cost, that it allows more new technology to be tested, and they are testing much quickly. Because this mission, the mercury ion clock, I heard about this like 2-3 years ago, and they rushed it very quickly. They're like, this took much longer. The rubidium clock that is in GPS took much longer from design phase to actual launch. This is much quicker than that. So that is like when some people say space is getting more accessible, it's becoming more cheap. Yes, it is. Like, this is the advantage of it. This is the basically fruits of our labor basically. So SpaceX is actually making it feasible. Because could NASA have done this? Yes, sooner or later they would have done it. They just would have waited for, okay, do we have one launch that is like planned for like overpowered, it has more than enough delta V, so we can tack it on, rather than like okay, just put it on, it's cheap enough. So it is a very good backbone technology. Many things can be possible if this works out, but this itself is not basically ground laying, it's just a foundation testing. So we cannot talk about SpaceX and Falcon Heavy and all that without talking about the landing. However, let's just put it this way, the landing was rough. They had very rough landing. So the center core failed, but this was kind of expected, simply because even before the launch happened, Elon Musk specified that there is 50-50 chance of center core landing safely. The reason why, because they had such a complicated fairing, the weight was so high overall, and they have wanted to push it so far ahead, they pushed the center core to upper maximum. Now there is one step more, they can push it even more, but that time they won't be able to land it. So that will be use and throw. But in terms of basically reusable, this is the highest they can put. So what they did, they fired it as high as like possible, highest g-force they can pull off, and they fired it. Now problem with that is that the landing trajectory went too far into the sea, so drone ship has to be placed very far apart. So okay, that's happened. Now problem with that, during the re-entry burn, when the rocket flips and fires the main engine towards the upcoming atmosphere, it slows down. Now during the slowdown, because the delta V of the rocket itself was so high, it overheated. Now current hypothesis is basically center core engines, because it was firing continuously, and the two secondary engine, they suffered heat damage, but center core engines, basically gimbaling system got destroyed. So when it was landing, the three engines were used to slow it down. Now that worked flawlessly, but once it's about to, like, at the barge level, it cuts off the two side engines and only relies on center engine to provide finer thrust control. But because the gimbal was damaged, it failed. That is why, like, it could have been like almost they could have landed, because if you saw the live stream, you would literally see plume of rocket exhaust literally reacting with the basically deck of the drone ship. It was like almost, they like almost cut it. But then again, like, this is the third time, and I think the center core may be cursed, because first time they flat out missed it. Second time, even though successfully landed it, they failed to retrieve it. During retrieval, something happened, it tipped over, and this time it flat out went kaboom. So I don't think they have very good luck with center cores. However, the side booster happened perfectly, no worry about it, so it just worked. This is, they have nailed it down. They're like, they know how to land side cores, like, they're good. So I think in next 3-4 missions they will figure out how to land center core without destroying it. So, but side boosters, awesome, no problem. Center core, they knew there was very low chance and it failed, but it came very close. It's like, you can almost see, I saw that in live stream, it's like almost got there. Then we come to the big first for SpaceX. This is the first time their boat that they are using for capturing the payload fairing worked. Now payload fairing can be reused if it touches the sea. They just don't want to do it because it adds a refurbishment cost, not because it will be damaged, but they have to double check it because seawater is corrosive. So you have to understand, they don't want the payload fairing to touch sea. So that is why they have this giant boat. This is the first time half of the fairing was recovered. This is the first time. Like, you have to understand this. Something is falling from space, which has a parachute, like a kite parachute kind of thing, to guide itself. Basically, it's on the mercy of wind. Then you have a boat which is not very, like, boats are not very agile creatures, so they take time to turn and all that. And somehow they figured it how to land it. Now, again, this is on the early stage. I think they will need bare minimum 10 to 20 catching attempts before they nail it down. Same way they have nailed down the basically return on land landing. It will take time to do this, but this is the first step. This is like you are seeing a foundation being laid down. So this entire mission is just that, because in the history book this mission would be very important, not because there was some military contract and all this, simply because it tested the green fuel, which will allow basically schools, labs, and basically small companies to make very powerful satellites. Solar sail was tested, which will allow maybe new things, especially if you want to use laser propulsion. Then the fact that they are actually trying to successfully capture the payload fairing, if it works out, this will also reduce the cost. And the deep space mission, the fact of mercury ion clock, if that works out, that will also unlock a high gigabit connection to basically Mars and Pluto. So there is a lot of foundation mission being tested here, and this is the basically main selling point. The reducing of the cost of the basically whole space industry has finally started to yield results, because this sort of mission would have happened without SpaceX, but they would have taken much longer. These sort of mission would have happened in 2030 at best. So the fact that they are happening this early, like, iterative process. So it's really we are seeing the beginning of a good age of space exploration. So this was my presentation about basically SpaceX Falcon Heavy second launch mission. I hope you liked it, learn from it. In that case, please leave a like. If you didn't like it, don't worry about it. You can press dislike. I would urge you to press it twice to show me your extra disappointment. Please leave a comment because I reply to all of them. Check out my all other videos that you are seeing here, and please subscribe, press the bell icon if you're free, and as always, thanks for watching.